You are watching channel number Collage. Through this channel, we take sincere efforts to make you understand and like mathematics in a simple and easy manner. In this video, we will understand trigonometric ratios of complementary angles. Now, what are complementary angles? Two angles whose sum is 90 degrees are called complementary angles. In right triangle ABC, angle B is 90 degrees, so angle A and angle C become complementary angles. Therefore, in this right triangle ABC, we can write angle A plus angle C equals 90 degrees. Now we write angle C in terms of angle A. So we write angle C equals 90 minus angle A. Now in right triangle ABC, we write sin A equals BC divided by AC. Also we write cos C equals cos 90 minus A because angle C is same as 90 minus A. So cos 90 minus A equals BC divided by AC. Now sin A equals BC divided by AC and cos 90 minus A equals BC divided by AC. Therefore, we can write cos 90 minus A equals sin A. So this is our first relationship about trigonometric ratios of complementary angles. Also, we have cos A equals BC divided by AC. And sin C equals sin 90 degrees minus A because angle C is 90 minus A. So it will be BC divided by AC. Now sin 90 minus A equals BC divided by AC and cos A equals BC divided by AC. So we can write sin 90 minus A equals cos A. In right triangle ABC, angle C is 90 minus A. We write tan A equals BC divided by AB and cot C equals cot of 90 minus A because angle C is 90 minus A. So cot 90 minus A equals BC divided by AB. Also tan A equals BC divided by AB. Therefore we write cot 90 minus A equals tan A. We have cosec A equals AC divided by BC. And sec C equals sec 90 minus A, which will be AC divided by BC. Since sec 90 minus A equals AC divided by BC and cosec A equals AC divided by BC, therefore we can write sec 90 minus A equals cosec A. We write trigonometric ratios of complementary angles. We have right triangle ABC where angle A and angle C are complementary angles. We write angle C in terms of angle A as 90 minus A. Now we write all the 6 trigonometric ratios of complementary angles. We write cos 90 minus A equals sin A, sin 90 minus A equals cos A. Cot 90 minus A equals tan A. Tan 90 minus A equals cot A. Sec 90 minus A equals cosec A. And cosec 90 minus A equals sec A. Here we observe that cos changes to sine or sine changes to cos. Cot changes to tan or tan changes to cot. Sec changes to cosec or cosec changes to sec. Now we will solve problems based on trigonometric ratios of complementary angles. Evaluate tan 65 divided by cot 25. Here 65 and 25 are complementary angles. We can change tan to cot, cot to tan. Here we will change cot to tan. We have cot A equals tan 90 minus A. So we write cot 25 equals tan 90 minus 25, which will be tan 65. We have the expression. Here we will write tan 65 in place of cot 25. So we get tan 65 divided by tan 65, which will be 1. So the value of this expression is 1. Evaluate sin 18 divided by cos 72. Here 18 and 72 are complementary angles. We can change sin to cos or cos to sin, but here we will change cos to sin. We have cos A equals sin 90 minus A. So we write cos 72 equals sin 90 minus 72, which will be sin 18. So in this expression, in place of cos 72, we will write sin 18. Sin 18 divided by sin 18 will be 1. So the value of this expression is 1. Evaluate cos 48 minus sin 42. Here 48 and 42 are complementary angles. We can change either cos to sin or sin to cos. We will change cos to sin. So we write cos 48 equals sin 90 minus 48, which will be sin 42. Now in this expression, in place of cos 48, we will write sin 42. So we get sin 42 minus sin 42, which will be 0. So the value of this expression is 0. Evaluate cosec 31 minus sec 59. Here 31 and 59 are complementary angles. We can change cosec to sec or sec to cosec. We will change cosec to sec and write cosec 31 equals sec 90 minus 31, which will be sec 59. Now in our expression, we will replace cosec 31 by sec 59 and write sec 59 minus sec 59, which will be 0. So the value of this expression will be 0. If tan 2a equals cot a minus 18, where 2a is an acute angle, find the value of a. Here we can change tan to cot or cot to tan, but we will change tan to cot. We write the expression first. Tan 2a equals cot a minus 18. Now we will write tan 2a as cot 90 minus 2a equals cot a minus 18. Now on both sides there is cot ratio, so we can equate the angles. So we write 90 minus 2a equals a minus 18. We take this minus 2a to the right hand side and take this minus 18 to the left hand side and write a plus 2a equals 90 plus 18, which will be 108. Now 3a will be 108, so a will be 36 degrees, which is 108 divided by 3. So we get a equals 36 degrees. If sin 3a equals cos a minus 26, where 3a is an acute angle, find the value of a. Here also we can change either sin to cos or cos to sin. We will change sin to cos. Let us write the expression first. Now we will change sin 3a or write sin 3a as cos 90 minus 3a equals cos a minus 26. Now here on both sides there is a cos ratio, so we can equate the angles. So we write 90 minus 3a equals a minus 26. We take minus 3a to the right hand side and minus 26 to the left hand side and write a plus 3a equals 90 plus 26, which will be 116. So we get 4a equals 116. So a will be 116 divided by 4, which will be 29. So a is 29 degrees. Express cot 85 plus cos 75 in terms of trigonometric ratios of angles between 0 degrees and 45 degrees. If we change cot to tan, then we will have to subtract 85 from 90, which gives us 5 degrees. And if we change cos to sin, then we will have to subtract 75 from 90, which gives us 15 degrees. Now 5 degrees and 15 degrees, they lie between 0 degrees and 45 degrees. So we write cot 85 as tan of 90 minus 85, which gives us tan 5. And we write cos 75 as sin of 90 minus 75, which gives us sin 15. Now we write the expression and substitute the values: tan 5 for cot 85 and sin 15 for cos 75. So this is our expression of this in terms of angles between 0 and 45 degrees. Next, evaluate tan 65 divided by cot 25. Here we can change tan to cot or cot to tan, but we will change cot to tan and write cot A equals tan 90 minus A. So cot 25, which is this, will be tan of 90 minus 25, which will be tan of 65. So in the expression, we will replace cot 25 by tan 65. So tan 65 divided by tan 65 will be 1. So the value of this expression will be 1. Show that tan 48, tan 23, tan 42, tan 67 equals 1. Here 48 and 42 are complementary angles and 23 and 67 are complementary angles. So we write tan 48 and tan 42 together and tan 23, tan 67 together. So we write tan 48, tan 42 multiplied by tan 23, tan 67. Now we will change tan 48 and tan 23 in terms of 42 and 67. So first we write tan 48 equals cot of 90 minus 48. which will be cot of 42. Cot 42 equals 1 divided by tan 42 because cot and tan are reciprocals of each other. Tan 23 we can write as cot 90 minus 23, which will be cot 67. This can be written as 1 divided by tan 67 because cot and tan are reciprocals of each other. Now we write our expression as LHS, in which we will replace tan 48 by 1 divided by tan 42 and tan 23 by 1 divided by tan 67. Now here tan 42 gets cancelled, tan 67 also gets cancelled, so we get 1 here, which is our RHS, right hand side. So in this manner, left hand side equals right hand side. So this statement is proved. If tan A equals cot B, prove that A plus B equals 90. We have tan A equals cot B. We can change tan to cot or cot to tan. But here we will change cot B and we write tan A equals tan 90 minus B. Here on both sides we have tan, so we can equate the angles. So we write A equals 90 minus B, which will be A plus B equals 90, which is to be proved. Next, if sec 4A equals cosec A minus 20 degrees, where 4A is an acute angle, find the value of A. Here we can change sec to cosec or cosec to sec, but we will change sec to cosec. So we write sec 4A equals cosec 90 minus 4A. So we will replace this sec 4A by cosec 90 minus 4A and write cosec 90 minus 4A equals cosec A minus 20. Now here on both sides there is cosec, so we can equate the angles. So we write 90 minus 4A equals A minus 20. Now we will send this minus 4A to the right hand side and minus 20 to the left hand side and write 4A plus A equals 90 plus 20. It will be 110. 4A plus A will be 5A, which equals 110. So A will be 110 divided by 5, that is 22 degrees. So A is 22 degrees. If A, B and C are interior angles of a triangle ABC, then show that sine of B plus C divided by 2 equals cos of A divided by 2. We know that in triangle ABC, angle A plus angle B plus angle C equals 180 degrees. Now here we have B plus C and here we have A. So we will send this angle A to the right hand side and write angle B plus angle C equals 180 minus angle A. Now here B plus C divided by 2 is there and here A divided by 2 is there. So we divide this expression by 2 and write B plus C divided by 2 equals 180 minus A divided by 2. Now this becomes B plus C divided by 2 equals 180 divided by 2 is 90 degrees minus A divided by 2. Now we will take sines on both sides and write sine of B plus C divided by 2 equals sine of 90 minus a by 2. Now we know that sine 90 minus a by 2 will be cos of a by 2. So we get sine b plus c divided by 2 equals cos of a by 2, which is to be proved, and we have proved it. So this is about trigonometric ratios of complementary angles. If you like this video, please click like button, subscribe this channel to get more videos on mathematics. Share this video to the students of class 10 and their parents. Thanks for watching. Have a nice day.